Base times height divided by 2. All right. I like the more algebraic way of writing it. 1/2 base times height. Are we rolling? Okay, great. 1/2 base times height. So, all right, that's great. But here's my question. Where's the base? Which one's the base? 15, 10, 12. Which side's the base there, folks? She says 15. What do you say, Nick?
Whatever side it's laying on.
Whichever side it's laying on? Okay, that would kind of make sense, like that's the base. Why'd you choose 15?
Because it's on the bottom.
It's the horizontal. So if I were to just rotate this all around, then all of a sudden the 12 would become the base?
Yeah.
What if I was just kind of standing like this? Or kind of like, kind of like that. I mean, so the base depends on the orientation. Okay. Anybody want to challenge that? Well, the thing is, the base, it doesn't have to always be whichever side it is. Sometimes that's kind of the way that we normally are used to it. But the base can be any side. You choose. It doesn't necessarily have to be this one. It could be this one. But we could also choose that one over there as the base. But for this purpose right here, now let's go ahead and all go with what we initially like, and that's choosing 15 as the base. So, in that situation, what is the height? Give me some description. I mean, is the height on there already? No. So, you're talking to me, Ashley. What would you?
You have to make it cut it in half, basically.
Cut it in half. Okay. So I'm gonna draw some sort of segment, and I agree with you. It would be something kind of like this. All right. So that's the height. How would you describe that thing? I'll get you started here. That's a segment. It's a line segment which connects the base to, how would we describe this point right up here? Okay, vertex. Specifically, we'll say to the opposite vertex. All right. Anything else you want to say about the height there, the base? Forms right angle? Ooh, I like it. And forms a right angle. Or we could say it's the perpendicular distance. Or we could say it's the shortest distance, because in geometry there's a theorem that says the shortest distance between a point and a line is the segment which is perpendicular to the line that passes through that point. Alright? So yeah, definitely perpendicular. There's the height. Okay, so that makes sense. So let's go ahead and draw the same triangle, or kind of almost the same way. If I had chosen this guy over here to be the base, then maybe something like right there, like that would be the height. And if I had chosen this over here to be the base, then that would have been the height. And the interesting thing is that whichever side you choose as the base, and then the height, those two numbers multiplied together times 1/2 will equal the area. And if it's the same triangle in each case, then the area is the same, but you get two different sets of numbers multiplied together to equal the same thing. You know, for instance, like 12 and 2 both multiply to get 24, but so is 8 and 3. So the height and the base numbers change, adjust accordingly, so you still get the same area. All right, good. Let's deal with a right triangle. Which side is the base? Okay. The correct answer is any side could be the base, but yes, in another sense, you're correct that we could say that that's the base, since that's the one that we're always used to. And then the height in a right triangle would be the other leg. But like I said, you could choose another side for the base. Like for instance, I could choose that one as the base, in which case that would be the height. I could even choose the hypotenuse to be the base. I don't know why I would do such a thing. But if I did, then the height would be that guy right there. Maybe all I have is hypotenuse. I don't know what the lengths of the legs are. Okay, we've established a pattern, and by the rule of three, which is the comedy rule, you always, do something, tell them one thing, and then you tell them something else kind of in the same vein that kind of gets them going, just to know that there's a pattern, and then you throw them the duck. Okay? It was kind of fun. It was not really good movie. But the point is that the rule of three is that the punchline is always in the third one. All right? All right, so I've set up a situation here. And now I'm going to throw us for a loop, because where is the height going to be if this is my triangle and I play your game and put the base right there?
Where's your height?
Where's the height?
Don't you have to like draw a line from the top one straight down?
Mm-hmm. Yeah. What you have to do is you have to extend the base out, and then you can drop the height down there. Which, I mean, that makes sense. If this was some sort of building that was kind of odd shaped like that, and you were at the top of it, your friend was there with you, and the friend said, "How high are we?" Well, you would look down to the ground, and that's how high you would. That's your answer. Okay. However, that picture of the height does not match our definition. Our definition says the segment which connects the base to the opposite vertex, and this segment connects the vertex but not to the base. You see what I'm saying? So we have to go back and modify our definition. We have to say connects a line containing the base to the opposite vertex. All right, that being said, let's go ahead and solve some problems. It's like the musical chairs table, sort of like whoever shows up, like gets that table. The other day, Kayla, you were gone, Janie and Kayla were sitting here. So now both of them are gone, and you two are sitting there. It's for like a wild card table. All right, so I think there's two, maybe even three Alex topics here, okay? So it's dealing with areas of triangles. The first couple that we're going to look at are right triangles. Then we're going to look at some triangles that are side angle side situation. And then we're going to look at some triangles that are side 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 situation and find the areas of those. And the reason why we want to find the areas of triangles is because everything is triangles. Everything is triangles. Okay? You want to find the area of a landmass, triangles. Break it down into triangles. You want to find the area of some irregular thing, break it into triangles. You want to find, you're doing some sort of computer simulation, you want to find surface area stuff, break down triangles. Okay? Everything's triangles. The world is triangles. Alright?
The world is a triangle.
The world is a triangle. It would not surprise me if, those flat earthers, okay, I'm not going in, but if they said that the world is a triangle, I might believe them. Alright?
Yes.
Because a triangle is
Finally, something I can get
ubiquitous. I mean, it shows up everywhere. Okay, so here we go. Find the area of the triangle. Okay. Right nearest 10th, right intermediate computations. Okay, that's great. So my formula is 1/2 base times height. Which side do you want to be the base? The 19. Okay, that's fine. Base. But then what in the world is my height going to be? Law of sines. Okay. Yes, we could, because we can say that's 35, and so this one over here is 55. And so we could say sine 55 over 19 is sine 35 over this. That is a way of doing this. But I want you to walk with me down memory lane. Go back a little bit farther. There is another way that we could solve this without law of sines. Jeremy, what are you thinking?
Well, you can do like tan 35 equals h over 19 and then just solve for h.
Yeah, do tangent. Just your good old right triangle trig. Remember that guy? Yeah. I recognize 35. Over here we've got an opposite and an adjacent. Okay, so he says the tangent ratio is h over 19. I agree. I'm gonna save y'all some calculator steps here. So h equals 19 times the tangent of 35. Don't type that in yet. Stay that finger, Nia. All right? We're just going to leave it as 19 tan 35. Beautiful in all of its exactness. What's the formula for the area of a triangle?
Half is base.
1/2 the base, which is 19 times the height. 19 tan 35 degrees. So you just saved us a little bit of time here. So now all you have to do is type in 1/2 times 19 times 19 times tan 35, enter. You don't have to worry about rounding intermediate calculations and whatnot. What do we get, folks? Round?
126.4.
I hear 126.4. They don't give us units, so we won't give them units. So, unit squared, that's the area. Question, Mason? Nope. Understand it, Mason? All right then. If you can do number 1, then you can do number 2. So let's go number 3. That takes care of the first problem type, with right triangles. Now let's look at the second problem type for today. That deals with finding the area of triangles side angle side. So, which side would you like to be the base? 8? Okay. So if that's the base, you might be wrong, but I'm going to let you figure it out if you're wrong. So if that's the base, now we can draw the height. That's kind of neat. When I did that, it formed a right triangle.
Whoa.
Do you see the right triangle, Haley?
Yes.
Yeah, with the 36 and the, okay. And I've got the 5 right there. John, share with us your moment of revelation there.
Since we know it's 90, so we just find the other angle, and then we do the tangent.
Okay, so what is that other angle? 54 degrees. So you want to do tangent, right?
Yeah.
So write that equation out there for me. Tangent of 36 or 54? You like tangent 36?
I like to put the one that's already on it.
Okay, that's all right.
Just to make it
Tangent 36. In this case, since it's a whole number, I mean, you're not gonna, and we're not doing any round up errors. 54 would have been just as fine as well. But that's fine. Equals. Keep going, John.
Question mark or over 8? No. Yeah, you have to do.
So if we're doing, okay, so 36. So there's that. So the tangent is the opposite, correct? So let's just write h. Over, and then it would be the adjacent side, right? You don't like that? Why not?
Because
we have 8, and that's the whole side.
8's the whole side. I agree. We do not know this, and we don't know the h. Sorry, John. Tangent
So
36.
8 isn't cut in half then?
It is not.
No.
The only time you're guaranteed that the height bisects the base is in an isosceles triangle, which is also equilateral, you know,
Yeah.
our definition of isosceles equilateral. But anyway, sorry, but tangent 36, I do like the 36 degrees, but I don't think tangent's the way to go here. Somebody else have another trig ratio they want to try?
Sine.
I hear sine. So sine of 36 would be the opposite, so that's h over the hypotenuse,
Which is fine.
which is 5. Okay,
It's
That makes sense.
it is sine. Multiply both sides by 5, I get h equals 5 sine 36. Don't touch that calculator yet.
I almost did, I was like.
That's right. Let's go straight to the big one. The area, 1/2 times the base, which is 8, times the height. 5 sine 36 degrees. So lovely. We apply our math. What do you get, Haley?
11.8.
They decided to keep us on our toes and want us around at the nearest hundredth on this one. So 11 point,
7.6.
I agree. They did give us units on this one, so we'll throw those units right back at them. But it's gonna be meters squared, since we're talking area of the region. Okay, that handles the side angle side situation. Let's see if we can look at number 4. Which side would y'all like to draw as the base? Where do you want the base to be? 11 or 9? You can't answer, Ashley. You answered the last one. What do you like, Rosa? 11 or 9? I like the 11 too. Because now it looks exactly like the last one that we did. Right? Okay. We don't need to do any more of that. There's your height. You can solve that now. Follow that other one's example. Ooh, what about this one? Number 5 is definitely one we. So Ashley's out, Rosa's out. Somebody else suggest the base, Nia?
15.
She likes 15 as the base. I'm not going to
I think I like that.
throw it out immediately, so maybe there's a chance. Now, if that's the base, this is that weird one, right?
You have to extend it.
We do have to extend it. Okay. So there's the height. I like the fact that that creates a nice right triangle over here with a hypotenuse of 9.
Oh,
But I'm not seeing any other information there. I mean, I don't have height, obviously. I don't have this. Do I have any information?
Can't you take the 149 and get that other side?
If by other side you mean the other angle?
Other angle.
Yeah, you could. What is, because this angle right here and 149 form a linear pair, they're supplementary. 180 minus 149 is 31 degrees. Aha! Now let us write a trig ratio to figure out what h is. What do y'all like? Sine, cosine, tangent? I'll circle the angle. This is the opposite. So it's the hypotenuse. Yeah, sine. Noticing a pattern here. I'm not going to tell you. Sine 31 equals h over 9. So h equals 9 sine of 31 degrees. Don't touch that calculator yet. Height is 1/2 the base times the height. 9 sine 31. Interesting that if you are one for noticing patterns and what we did with the other one and how it resembles this, is that it works even for obtuse angles like that. It's kind of cool. And the calculator says I think it's in the 30s.
34.7
I agree. And the units.
centimeters squared.
But if you go to Lowe's and you ask for a 100 meters, 100 foot squared bit of carpet, they might kind of look at you kind of weird. You'd say square feet, or in this case, square centimeters. In this math, this is a safe place, we can say centimeters squared. But go to Lowe's or Home Depot, say square feet, or square yards, or whatever. Alright, that takes care of the second situation, side angle side. Let us now go to the third situation. Side, side, side. Alright, which side do y'all want to start with? Which side's your base? We don't need to do the base.
16.
Okay, that's as good as any. Okay. So if that's the base, there's my height. I need to figure out what this angle is right here. Any idea on how to find an angle? In a side situation? We have discussed a way of finding an angle given a side. Law of cosines, yeah. We could use law of cosines to find that angle, and then we could go and do all the stuff that we've already been doing. Okay, are you okay with me saying that?
Mm-hmm.
But we're not going to do it that way.
Oh.
Because there was a guy
Right.
who was a hero. All right, he's a hero for all of us because he found out a way with this crazy long, process of determining a nice formula for the area of a triangle given all three sides. This guy was a hero, and we call his formula the hero's formula.
They really though?
Okay. Well, I'm going to. In previous classes, we wrote out the whole. I proved it to them step by step. But it's a page and a half, single space proof. Okay. So instead, what I've done is I have printed it out for you.
Oh, wow. Thank you.
Wow, that's one.
And so now what I do is I give students an extra credit opportunity. If you want some extra credit, put down on each one of these lines the justification. How did you get from this line to the previous line? How did you get to the next line? How did you get to the next line? And I might use that to replace 3 or 4 topics or something like that. Maybe 3 topics. If you're kind of shy, a few topics.
Good grief.
Oh, God.
This looks
Now you can see why they call him the hero.
Well, it's not.
Oh, wait a second. It doesn't say hero at the top, it says heron. Hold on a second.
Is that a bird?
A bird.
It's like heroin to me. I think that's what he was on when he was solving this.
Alright, here's the answer to the riddle. We are both correct. Heron's formula is named after Hero of Alexandria, a Greek engineer and mathematician. You can use this formula to find the area of a triangle using the 3 sides.
This is a lot.
Alright? So it's Heron's formula. Yeah, you add them all up and divide by 2.
Wait.
That's to get to the, well, hold on. So let's look at this.
I'm like, wait, really? That's it?
No, not entirely. So anyway, just to be clear, if you want extra credit, go ahead and identify what takes place on each step. It's literally just algebra. Okay? I think one of them is like the Pythagorean theorem. There's no trig. You could have done this in algebra too. This is the copy of a copy, so it's getting kind of weak there. But let's go back to this problem. According to Heron's formula, he creates this thing called the semi-perimeter. okay? The semi-perimeter is 1/2 of the perimeter, hence the semi. Alright? So that's going to be A plus B plus C divided by 2. Then, what you do is you plug it into this formula. The area is equal to the square root of the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus side C. So, in our situation, the perimeter is 12 plus 14 plus 16, which is, you get a kick out of this, 42. Divided by 2, 21. So area is 21 times, I guess I'll write it out here, it doesn't hurt me too much. 21 minus 14, 21 minus 16, and 21 minus 12. So 21 times 7 times 5 times 9. So multiply those all together, then take the square root, and let me know what you get. 81.3 is the final answer. You are a hero, Hannah. Or maybe you're a heron. Hard to know. I don't know why it's called Heron's formula. We saw that it's named after the hero. There was a man named Hero. Y'all are in honors class, and I don't really feel the need to do more plug and chug problems with you. Is that okay?
It's 81.3.
81.3. That's just me forgetting the last number that you said. So yeah, 81.3 is correct answer. Number 7 is exactly the same, and number 8 is exactly the same situation there. So today, class, we talked about some different ways of solving the area of a triangle. Alright? The first way was just using right triangle trig. The second way, we drew heights and then used right triangle trig. And the third way, we used Heron's formula. And you can be a heron too. Alright? And that's it. Tomorrow's work day.